welcome to my vlog. Today, samahan niyo ako bilang isang AB Engineering students as we explore the second law of thermodynamics and entropy. Ready na ba kayo? Ano, tara?
Good day everyone, I am Bretel Divine Algazar and today I'll be discussing the second law of thermodynamics and entropy. Let's first look at our objectives. At the end of this lesson, the student should be able to learn what is the second law of thermodynamics and entropy are, how heat naturally flows, how a heat engine works, and how to calculate its efficiency. So, what is the second law of thermodynamics? This law tells us the heat naturally flows from a hotter object to a colder object. For example, kapag may mainit kang kape at iniwan mo lang sa mesa, lalamig siya after a few minutes. Pero, mapapansin ninyo, hindi kusang iinit ang malamig na kape. Why? Because heat naturally flows only from high temperature to low temperature. Another important idea that every time energy is transferred or converted, some of it becomes unusable. Kaya kahit gaano kaganda ang design ng machine, may energy pa rin nawawala bilang waste heat. This slide explains the behavior of energy. In nature, the second law explains the direction of energy transfer. Heat always moves from hot to cold, at habang nangyayari ang process na iyon, the system becomes more disordered. That increase the disorder is what we call entropy. So, kapag narinig ninyo ang word na entropy, isipin lang ninyo measure of disorder. Now, let's look at this picture. On the left side, mapapansin natin na kalat-kalat ang particles. Since random ang arrangement nila. This represents high entropy, meaning mataas ang disorder. Habang papunta tayo sa right side, mas organized siya. Mas organized ang particles. That represents low entropy. Now, here's the important part. According to second law, nature always tends toward higher entropy. Meaning, mas natural maging magulo ang system kaysa maging organized. A simple example is your bedroom. Kapag nilinis mo ngayon ang kwarto mo, organized siya. Pero after several days, without cleaning, kusang maging magulo ulit. And our next slide emphasizes that natural processes happen only in one direction. For example, kapag may yelo tayo na ilalagay natin sa labas, matutunaw ito. Pero hindi kusang babalik ang tubig sa pagiging yelo. Kailangan pa natin itong ilagay sa freezer. Again, heat naturally moves from hot to cold and not cold to hot. If you want heat to move from cold to hot, kailangan ng external work. Gaya nga ng tubig, para mabalik siya into cold, from cold to hot, and hot to cold. From cold to hot, we need to put some effort para maibalik siya. So in this diagram, our picture shows, makikita natin ang dalawang objects. The first object has a higher temperature while the second object has a lower temperature. Because of the temperature difference, heat flows naturally from the hot object to the cold object. The formula shown here, delta S is equals to Q over T, is used to calculate entropy change, where the Q is the heat transferred, the T is the temperature in Kelvin. This means that entropy depends on how much heat transferred and at what temperature. Now, let's move to heat engine. A heat engine is simply a machine that converts heat energy into mechanical work. Examples include gasoline engines in cars, diesel engines, steam turbines used in power plants, and jet engines in airplanes. Their main purpose is to produce useful work from heat energy. Next is, I have a picture to show to you. And this picture shows how a gasoline engine works. There are 4 strokes. Which is the first is the intake stroke. This is where the air fuel enters the cylinder. Second is the compression stroke. The piston compresses the mixture to prepare it for combustion. The third one is the power stroke. The spark plug ignites the mixture, creating an explosion that pushes the piston downward. This mechanical work is produced. And lastly, but not the least, is the exhaust stroke. The burned gases leave the cylinder. Although combustion produces a large amount of heat, not all of that heat becomes useful work. Some of it always lost as waste heat. The next slide, heat transfer from the hot object or hot reservoir. So this diagram explains the energy flow inside heat engine. The engine receives heat called QH from the hot reservoir, which is in this in the upper part of the heat becomes useful work, represented by W here. And the remaining heat, called QC, is released to the cold reservoir. This is the reason why heat engine can ever reach 100% efficiency. Next, so what is efficiency? Kay natakal to ganinang about sa efficiency. Kung unsa man jud na ang efficiency gidi ay. So, the efficiency tells us how much of the supplied heat becomes useful work. Ang nasa ubos kay unsa ang formula sa efficiency. So, efficiency is equal to work divided by heat supplied. The higher the efficiency, the better the engine performs. However, because some heat is always rejected, the efficiency is always less than 100%. Next, and this illustration shows or picture that the heat entering the engine divided into 2 parts. The available energy and the unavailable energy. The available energy is converted into useful work, while the unavailable energy is rejected as waste heat. Beside, it is the pressure volume diagram. The enclosed area inside the graph represents the net work produced during one complete cycle. And this slide explains why heat rejection is necessary. The heat supplied to the engine is always greater than the useful work produced. So why? Because some heat must always leave the system. That's why thermal efficiency can reach 100%. The goal of engineers is to design machines that minimize heat loss as much as possible. At tumaya naman tayo dito sa two ways in which second law express. So first is the Kelvin-Planck statement. The Kelvin-Planck statement says that it's impossible to build a heat engine that converts all heat from one source into work. No matter how advanced the engine is, there always be heat rejected. That's why perfect efficiency is impossible. Next is the Clausius statement. It says that heat cannot naturally move from a colder object to a hotter object. For that to happen, external work is required. A perfect example is a refrigerator. It uses electricity to remove heat from inside the refrigerator and release on it outside. And now, let's discuss the entropy formula. The formula of entropy is delta S equals Q divided by T, where delta S is the entropy change. The Q is the heat transferred and T is the absolute temperature in Kelvin. If more heat is transferred, entropy increases. If the temperature is lower, the entropy change becomes even greater. Let's solve our example. A system absorbs 600 joules reversibly at a constant temperature of 300 Kelvin. Find the entropy change. So the given values are heat equals 600 joules and the temperature equals 300 Kelvin. Using the formula, delta S equals Q divided by T. So we substitute the values. 600 divided by 300 equals 2 joules per Kelvin. Therefore, the entropy change is 2 joules per Kelvin. In conclusion, the second law of thermodynamics tells us that heat naturally flows from hot object to cold objects, and that no energy conversion process is perfectly efficient because some energy is always lost as waste heat. Meanwhile, entropy measures the amount of disorder in a system, and according to the second law, entropy naturally increases as processes occur. So understanding these concepts helps engineers design more efficient engines, turbines, refrigerator, air conditioning systems, and many other technologies. And that's the end of my presentation. Thank you for watching. Babush!